It is time. Ladies and gentlemen, welcome to Tech Interview Live. Today I'll be your host, and my name is Adam. And I will be joined with a very special guest, Ankita, right?
Yes. Hi.
Hi, Ankita. Would you like to introduce yourself to the chat? Tell a little bit about your technical background and maybe your life story if you want to go ahead and basically say whatever you want about yourself.
Sure. Hi. So I've been in the industry for about 2 years now, and I've been on the software infrastructure team. And right now, I'm looking for my next role. So yeah, I guess that's me.
Well, nice to meet you, Ankita.
Nice to meet
So,
you too.
are you feeling ready for this challenge?
Yes. Yes.
Yes. That's what we like to hear. So, basically, I chose two medium questions and we'll go as in depth as we can with like the first one, and I chose like a second one in backup just in case if like you already know the first one because that can happen. And
Mhm.
I think generally if you already like know all the ins and out of a problem, it's like a less good indicator of how like you solve problems in general.
Mhm.
So I took two just in case, and hopefully you don't know both of them, but if that happens, well, try to focus on like how you explain the problem to the interviewer, because if you can't show how you solve problems, you can at least like try to demonstrate your communication skills. Does that make
Okay.
sense?
Yes. Yes.
All right. So let's start by presenting the problem. I'll be copying it in the repo. Just give me a second.
Mhm.
All right. So here's the problem. It's called rain catcher. Have you heard of it?
I've only heard of it, but I haven't ever solved it.
Okay, good. That's good. Because I think that's a really good problem because I already had it in an interview and like I think I did pretty poorly, but I ended up getting an offer. So it always depends like how you like approach the solution you have and how you explain it. Like a lot can vary, and since
Right.
there's many factors of luck, like you never know. So I think it's good that you don't know it. So I'm excited to see what you will come up with because there's like some pretty various solutions I could say like to solve this problem that aren't all efficient, but they can be pretty creative, I'd say. Yeah.
Okay. Okay. Okay.
So don't hesitate to take your time with it. So I'll start by reading it first so you can like understand it better, I guess. And if you have any questions, don't hesitate to stop me. So
Right. Right.
you are given a list of non-negative integers, nums, where each element represents the height of a hill. Now, suppose it will rain and all the spaces between two sides get filled up. Return the amount of rain that would be cut between the hills. For example, given the input 212, we can hold 1 unit of water in the middle. So to illustrate this better, I could draw the hills for you. So let's say
Mhm.
like the hashtag is like a hill. So would have a height of 2 here. Then in the
Mhm.
middle, we would have a height of 1. And then for the last hill here, we will have a height of 2. So basically, we
Right.
want to fill the volume in the middle. So it would give 1. And like we assume that there's nothing on the side, so there can be any volume on the sides like this.
Right. Right. Okay.
So there's another example here. So given the input 301305, we can hold 3 units in the first index, 2 in the second, 3 in the fourth index, and we cannot hold 5 since basically it's just a walkthrough of this example. I can draw it for you. It would be like 3 like this, then 0, then 1 here, then it would be 3 here, like this. 0, 1. There's
Zero.
0, and now a 5 here. Like this. So it says would trap 8 units of water because there would be 3 here, then 2 here, and 3 in the last hole.
One, two, three.
Yeah, do you see it?
No, I'm just trying to count the spaces.
Okay, so here in the first hole,
Yeah.
there's 3 empty spaces that get stuck here. Then
Yes.
here you have like 2 here. So in total, this hole here has 5 units of space that
Okay.
get filled.
Okay.
And here, this hole has 3 units of space.
Okay. Okay. I see.
So the constraints don't matter really in an interview. Like you try to figure out the best you can, but like it's better to have like a working solution that is not as optimal than trying to like find the most optimal solution but not knowing what you're doing. So here are a few examples and with the output, so that's for testing. And that's pretty much the problem. Is there anything you'd like for me to clarify?
No, no, no. I think I understood the question.
Okay.
Uh, right. So, right. Okay. Okay. So, we basically would have to count the number of empty spaces and then just add them, and that would give us the final result. Okay. Okay. So, I have to figure out how to calculate the empty spaces, right?
Yeah.
Okay. Right. So the empty space between two hills. Okay. Uh, so if I have a tall hill and if I have a short hill, like for example, in the first question, 2, 1, 2. So
Yeah.
I have a tall hill that's 2 units tall, and then I have one, which
Mhm.
is 1 unit tall. Then I so in bit. So let's say if it was just 2, 1, then it would be holding just 1 unit of water, right?
Actually, we consider like the sides as being like empty. So the I can draw it for you. It would be like just flowing like out of the grid. So it would be like that. So if you try to put some water here, it would just go on the floor and like empty itself.
Okay, so then here it wouldn't be able to hold any rainwater. Okay.
Exactly. Yeah. It has to be between 2 hills.
Mm-hmm. Okay, it has to be between two hills. Okay.
Yeah. So if you'd like, you can start with like a simpler version of the problem, like where we would be limited to a input of size 3. So basically, we'll have just like I can add it at the bottom here. So instead of having like any arbitrary number of hills, we would have like, let's say like 3, 1, and 5. So we could draw it like here. So 3, 1, and 5 here. So I think this would help you like understand a little bit like the a simpler
Yes.
version, the pattern that can emerge. So
Right.
how would you approach like the problem if there's only 3 hills like this?
Okay. Okay. So, right, the amount of water it would hold would be the number of uh, the space in between, which would be so I have 3 and 5, right? So it would be the min of 3 and 5, right? So it
Okay, okay, yeah.
so like the boundary, like it cannot hold water that goes above um 3 units,
Yeah, okay.
right? Yes. So yeah, so I need to figure out those intervals, if that's the right word to use. You know, yeah, and oh, the empty space can only be if oh yes, the empty space can only be if, let's say, if I am considering say 3, 1, 5, if there is a number that is in between 3 and 5, because if it's a number uh, you know greater than 5, then that's something else. For example, if it was something like 3, 6 pi, then it wouldn't be able to hold any water.
Yeah, exactly.
Right. So if it's 315, it can hold some water. So okay. So it has to be less than this left and less than the right as well. Um,
Yeah.
yeah. Okay. Okay.
So do you have like a formula to compute like the value in the middle, the amount of water?
Um,
So you were on the right track with the saying that it's limited by the min of the neighbors.
mhm. Yeah, but I want to figure out, I mean, this is just a small example. So I'm looking at the bigger one here, and if you have something like, okay, okay, so I think you can only have space, if you know, if there is a separation between two hills, right? That's what I'm trying to formalize. The 315, that I'm trying to formalize the relationship there. It should not. Okay. It has to represent a valley. That's what I'm trying to formalize. If it represents a valley, and once I know that it does, then I can find the empty spaces within that valley. And once I've identified all of these valleys, then I can sum all of the empty spaces of within these valleys.
Yeah, that makes sense. So in the case, like, to keep things simple, in the case where there's only three hills, is there a
Mhm.
simple way to check if it's a valley?
Yes. Your if it's a yes. So the first element, the second element should be less than the first element, and the third element should be greater than the second element.
Yeah, makes sense. So for this example in particular, the what would be the answer?
Here the answer would be, the answer is 2, which is the min of the ends of the valley
Mm-hmm.
minus the middle value.
Okay, yeah, exactly. That's good. So I think yeah, you got the formula basically the min of the basically the edges of the valley minus
Yes,
like the floor we could call it.
yes.
So
Minus the plateau. Yeah, yeah. Okay.
yeah, so that's basically the solution for like the simple version. Now the challenge is like trying to generalize it to like higher dimensions.
Mhm,
So let's
mhm.
say we change this version of the problem just a little bit. So instead of having 315, we decide that we want to make the value larger. So we would have like 3115. So now instead of just having one hole, we had to deal with like multiple columns here.
Right.
So it kind of breaks your formula of saying like if the neighbors are like higher than the
Okay.
current, that it's a valley.
Okay. So then I would fix, say, a left. Okay, and then try and move rightwards, and stop at a point where it's greater than the left, means greater than the left value, greater than or equal to the left value. So if I I lock on 3. Okay,
Okay, okay.
and then I start scanning the next element. Okay, 1. Okay, 1, and now I see 5. Okay, 5 is greater than 3. I can fix a right end here.
Okay, okay, yeah. That
So then, yeah, so then I have a valley start and a valley end. And
so
okay.
so what happens if you never find a value that is greater than 3? Let's say you like instead of a 5 here, we would have a 2.
Okay.
Would your algorithm still work?
No, it would not. Then I should define my valley as the value that's just greater than the previously seen value. you know. So if it was say 3112, I could still catch some rain.
So you would iterate over the heights just to like understand better what you're trying to say. And then what do you check when you're on a value?
I would check the min of the ends of the valley ends, and okay.
What's the ends you're mentioning?
The end is you know the first instance when it's the first instance when I see some sort of a peak, you know. So 3 1 is downwards, 1 1 is on the same level, and 1 5 is upwards, right? So this is my
Mm-hmm.
first instance of a peak, right? So okay, so that's where uh, you know I end my scanning for now. I mean, I found my valley, and yeah, and then I try and calculate the empty spaces within. Um, okay.
Hmm. I'm not sure
Right.
if I understand everything super clearly. Maybe if you could like write some pseudocode to like illustrate it better before going
Mhm.
into like the actual code. Even though Python is kind of like pseudocode.
Yeah. I could write something.
Yeah, if you feel like it.
Right. Um, okay. So if it's empty, then we cannot catch any water.
All right.
Right. Okay. So now let me start with the ends of the valley. Right. Um,
Okay.
okay. My the length of my nums array should be at least 3. If not, then then the water just flows out. So
Yeah,
then
exactly.
I cannot catch any rain, right? So if len of nums is less than 3, again return 0 because no water can be got.
Yeah, good.
Now that I know it's greater than 3, I can now start scanning. You know, uh, I can now start scanning my array and see if I can identify something. If I can identify a valley, if I can find a valley. Okay. Um, okay. So let me see. Right. So I'm going to call this say something called pointer, which will start moving from the next element, right? Um, so let me do this. My pointer is the one that will probably will always reach first, so I can use that to break out of a loop. Um, um, okay, so I keep going. I mean, my pointer keeps going when it keeps seeing a downward trajectory, right?
Yeah. So
Right.
that's the
So
problem I'm seeing. How I'm not sure how you're gonna solve this with this method. So basically, you're gonna start from every position and like iterate until you find something greater or equal, right?
yes.
So let's say you have like I mentioned earlier, like a descending valley like this.
Mhm.
Like this one holds one
Yes, it
unit of
does.
water. So do you have a answer
Yes,
for this?
yes. So I won't be comparing it with the left. I would be comparing it with I minus one or pointer minus one. Because only that will sort of help me catch the water.
Pointer minus one. What does that represent?
It would present it would represent the position that I am at currently, if that is um, greater, I mean, if it starts an increasing sequence from there on. So so the way the value would be like, you have a point, and then you keep going downwards, 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 and then once you go up, you can start collecting some amount of water. So then I want to calculate the amount that I can hold right there at that point.
Hmm. Okay. Try to
So
like
the way I'm visualizing is here, okay, and then if I add another pound here, another pound signal here, you know, say if it's something like this.
yeah.
Uh, yeah. So once I have identified how much water I can catch here, then I would try and figure out how much I can catch here. Oh, okay. So then it goes in a W. Ooh, okay. Mm. Yeah. Okay. Okay. Oh,
So what would be
okay.
the
Right.
answer in this case?
Two,
Actually, it would be one, two, three, four, five
three,
because
four, five. Yes.
there's
Yes. The upper
the
one
holes. Yeah, exactly. So does that change your solution?
changes everything. Uh, gonna have to recheck the solution. Okay. Okay. Right. Okay. Right. 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 Okay. I'm not sure. But okay. If I start off with a value, okay. Okay. So then let me define my value as uh, greater than or equal to the start. Okay, and and all the values in between must be um, less than the max of both of them, right? So in this case, it's 3, 1, 2, 1, 5, right?
Yeah.
So yeah, then I only define my value when when I encounter something like 5.
Why? What's special about
No,
five?
no, I mean not 5, I mean a value that's greater than or equal to the left. Oh, yeah, yeah.
So I think I see what you're trying to say. It's basically when you know what the minimum is to the left, you know that the current column you're standing in will have the exact amount that is defined by this constraint, basically. Like since you know that the right wall has like a value greater than what you met on the left, you know that there can be enough water in the current tile to like fill up until the left wall, right? Does that make
Yes,
sense?
yes, yes, yes.
So is there some kind of pattern to be understood from this? Like you remember in the start we were just checking the minimum of the wall to the left and to the right. And now you're
Okay,
trying to
okay.
check if we know what the minimum is to the left, you can compute the value in the current column.
Yes. Okay, okay.
But
Okay,
it's breaking when it's descending. So is there some way that you could like find out basically the minimum to the left to the right, but for like
yes.
a an indefinite distance basically?
Okay, so okay. Okay, so maybe okay, how about this? Okay. Okay, so I figure out the minimum of say the right and the left. Okay. And okay, yeah.
Yeah. Go on.
Uh,
I think you have some good idea there.
I do, but I'm not able to extend that to a more general case. That's what I'm trying to figure out. So if I take, so I was thinking something like a two-pointer approach, but I'm not sure if it would work out. Uh, you know, something like I start from left and I start from right, and I find the min of both of them, and I fix a pointer there, and then I try and see. Um, where a valley could end, something of that sort.
Yeah, yeah, that makes sense. Yeah.
So okay, so if I do that, I start my left from zero and I start my right from the end of the array. Okay, um, and I've got my min. My left is my minimum. Okay, um, okay,
Yeah. Okay.
okay. So now that I've got left as my minimum, after
Let's
left.
like try to take an example and like walking through what your algorithm would do.
So, okay, so this is what I wanted to do. So, okay, now I've found three and I've found five. Okay, let's say there was another value here, say two, one. Okay, so in this case, this is what it would look like. I have something like this,
Yeah. Okay.
it, yeah, it. So if I then take a min of left and right, then that would be one, but then the water would just flow off here, right? So, how do I find that exact right point? Okay. Okay, so I've got three, right? And I've got one.
Mm-hmm. So here's a hint. Basically, the amount of water is constrained by the minimum of the like left
Mhm.
peak and the right peak. So how do you like find the left peak and the right peak? So let's say you're on the 3 and the 1.
Mhm.
Since you're constrained by the minimum, like how would you like how do you explain this? It's like you found out some approach, but it's like the super optimized approach that is not like the simplest, I'd say. So
No, no, I'm just trying to figure out the most simple way to recognize the value. That's where I'm actually having the difficulty. Uh, to find a foolproof way to recognize a valley where it's going to hold the water, right? Uh, yeah, so
okay, maybe I have like some kind of good hint. So let's take like an example. Let's say we put an additional constraint that we say that the peaks are always increasing. So actually, does that make sense? Like something like yeah, that makes sense actually. Just 1 second. So something like this. So I think like in this case your idea would work since you just like iterate and keep track
yes.
of like the minimum.
Yes, because here, there is a proper, way to end a valley, start and end a valley. Uh, yeah. So,
So what if we take the same example and we like put it backwards? Something like this.
yes.
So what can you do now? Yeah, actually. It's basically the same thing, but in reverse, right?
Yes, yes, you're right about that. Okay.
So I could give you another hint, but I think it would be like a major giveaway. So
Okay, I don't, okay, here's what I'm thinking. Um, I process them in small sublists of length 3, you know, and see if that forms a valley, be it uh, increasing or a decreasing valley. If so, uh, then I find out the area there. Okay, and then I move on to the next valley. So in one go, I don't process all of uh, these 5 elements. I start off with just 3 elements, see if that satisfies a condition. If not, then maybe I scan ahead.
okay,
I
could
don't know. There's some trick that I'm totally missing. I know it's the min, but how to smartly figure out the min? Oh God.
it's okay, it's okay. So yeah, I'm not sure how your sublisting would work with like some greater holes like this, where there's like a huge hole separating two peaks, basically. So okay, let's try to like focus on the definition of what is a peak and how do you find like the highest peak to the left of the current position and the right, basically. That's what will give you the solution, right?
Mm-hmm.
So the
Yes. So the peak would be, it would be greater than its left and its right. Only then it peaks.
okay, okay.
That's a
So
local peak. Like two peaks, because like two is a peak because there is one right next to it. So
but basically, like if we look at the simple version, you can like consider like the left of the position you're at and the right as like basically two sub problems where you have to find the peak in both of them, right?
yes.
And then when you find the peaks, you just take the minimum of both of them and then you can apply the same approach. Does that make sense?
Mm, It it does. Okay.
Do you think you can find the solution with the hint I gave you?
Yes, yes, I do realize that. I'm just trying to. Yes, yeah, I got what you're trying to say. Okay, so you're saying find a left peak and a right peak, and then take the minimum of those two peaks.
I don't know, you tell me.
Yes, of course. Oh God.
So you know how to find the peak, right?
Yes, yes, I do. Um, yeah. If it's the first element, then you know, I check if the next element is smaller than that. If so, then I have my left peak, and then I keep going till I find my right peak. Okay, okay. I think I could do that. So if I okay, so here I fix my first peak, my left peak, and then I go and I find my right peak. Okay, and here I could yeah, then I would see the distance and the area current. Okay, so I think yeah, once I figure out the peaks, I should be able to yeah, so I've got a left. Okay, okay, I see. So I just identify the left peaks and the right peaks, and for every such peaks identified, I find the area. Okay. Um, okay. I've been seeing the same thing over and over again, but okay. I want to do like
Don't
oh,
worry about it.
this is probably the worst interview that's going on record. Okay, okay. Maybe quite a left peak and the right peak, and I'll have some pointer move through it. Let me just qualify. Mm, okay, so I need to figure out my left peak. Okay, so if I is okay, sorry, if I is zero, I mean if it's the first element, um, and if this is lesser than the first element, then okay, I have found my left peak. Um,
Okay, let me think. So, if you're in the first position, so
just
basically your left peak will represent the. Oh, it's the index you're tracking. Okay.
yeah.
Do you actually need to track the index?
Once I've got a hold of the index, I can just figure out,
Okay,
yeah.
so I heard you wanted to compute the area, right?
Yes, yes.
So
Yeah, okay.
you want to like compute the water of like many columns at the same time.
Mm,
So you would find like a peak to the left and to the right and try to find all the water in between.
yes, yes.
And how would you remove the columns in the middle of the two peaks? So like in the case I'm highlighting at line 50 here, you would have like those two peaks here, but you still have like some height in the middle here that needs to be removed, yeah.
Okay, so
So
I was thinking of first identifying this as one value. Okay, like 312. Okay, um,
okay,
this would hold just 1 unit of water, right? And then from two, I then identify my next value, that is 215.
okay,
Oh, okay, I see. This would not work.
okay, I'll give you another hint, okay. So I think it's some simpler if you try to like find the volume that will be stuck at one given index. So instead of like trying to find all the water between two peaks, just like
Mhm.
find the water at one position. And the water stuck at that position will be
Mhm.
determined by the peak that you find in the left part of that array and the
Mhm.
peak in the right part, right? So
Okay.
maybe if you try to like concentrate, how do you find the peak in the right part of a position and the left part of a position? So what's a peak again? Just to make sure. Like the global peak.
Okay, a global peak. Okay, the global peak would be the highest, the hill that is the highest, right?
Right. So if I tell you I want to find the global peak to the left of a position
Okay, okay, okay,
and to the right,
okay, okay.
does it make sense? Do you see how it helps you solve the problem?
Yeah, yeah, yeah. Okay. Okay, the global peak at the position. Okay.
So let's say you were standing on the 2 here. You will want
Yes.
to find the peak like in the sublist to the left and
Mm-hmm.
here.
Okay. Okay. Okay, then that would just be the max in those sublists. Okay. Uh,
Exactly. Yeah, sorry.
mm, okay. 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 So then,
Okay, so let's say you have the value at a position, so let's say value equals 2, and I tell you
mhm,
the left peak is 3 and the right
mhm.
peak is 5.
Yeah.
Do you have enough information to compute the amount of water that will get stuck at that position?
Yeah. Then I think I could calculate the areas there.
So how would you do it?
Okay. I would take the min of both the peaks, right?
Yeah.
Uh, and subtract from it. Okay, the min would give me the vertical uh, units, but I would also need to subtract the hills in between, right?
Well, we're only computing the value at a given position, right? So I'll mark it with an X. We would like compute the water at that position here. But since we would like iterate for do the same process for every position, we would like do the sum. Does that help?
I get what you're saying, but I'm just not able to formalize it or find a.
Okay, I'll give you another example. So let's say for the same problem here, like I'm gonna erase this here. So let's say we start at the first position here. So y equals 0, so the value is 3.
Mm-hmm.
So what would be the left peak,
3,
excluding the current position?
5. No,
There's nothing to the left,
there,
right?
there's no left.
So what would be the answer?
0.
Yeah. What about the right?
The right would be 5.
Yeah.
Okay, okay.
So what would be the amount of water at that position?
Min of 3 and 5.
So 3?
Yes.
Does that does that work? Is that like the correct answer?
No,
Do you know why?
because we haven't considered the valleys in between. I mean, the hills in between.
In between the peaks?
Yeah.
Okay, yeah. I know why you're getting stuck on this. I really wanted to like when I first had this question in interview, I tried really solving the problem in that fashion, like trying to like iterate between peaks.
Uh-huh.
But if you like think of the problem as like columns of water, where like consider just one position and like fill it as long as you can, like this, then I think it's easier.
Okay, okay, okay.
So like at this position, there would be zero water, right? Because it would fall to the left, right?
Yes,
Because there's no peak to the left, right?
yes, there's no peak to the left.
And if you remember the first version of the problem that was with the length 3, do you
Uh-huh.
remember the formula?
Um, no, what did I say earlier?
Now I can remind you. You told me that we took both peaks of the valley
Yes,
and we took the minimum, right?
minimum of those. Yes, yes.
And then you subtracted the floor, right?
Y- yes, yes, yes.
So can you do the same thing here? So what's the minimum of the two peaks,
It's zero.
right? And what's the floor at the value basically?
That's three.
Yeah. So the formula would give us -3, right?
Okay, okay.
And that doesn't make sense, right?
Yes.
So how do you handle it? Basically,
Mm,
the negative value means that there's no actual floor. It's just coming out of the floor, so you're actually on the peak, right? So you couldn't consider it in the volume. Did I lose
okay,
you?
okay, okay, okay. Yes, yes.
Yes, I lost you.
Yes, no, no, you're right. So, okay.
So the amount of water would be 0, right?
Yes.
Okay, okay.
Yes.
So I'm gonna try to ask you the amount of water at one specific index and see if you got the logic. Okay.
Like, no, no. I'm still a little confused. I mean, I figured it out, but I mean, God. Okay, if there is no peak, I mean, if there is no left peak, then it does not hold any water, right?
Yeah, exactly.
Yes. Okay. So, all right. So okay. So at an index, if there is no left or a right peak, then we know then it's going to overflow, right?
Yeah.
And okay, so that's let's say index zero. So when we go on to index one, then we try and see if it has a left peak and a right peak.
Yeah.
Okay.
So in the case of index 1, is there a left peak and right peak?
Yes, there is a left peak at 3 and a right peak at 5.
Okay, so can we use that information to find the amount of water at that position?
It would be the min of the left peak and the right peak minus its own value because y-
Yeah. So the answer would be
it would be min of 3 and 5 minus 1.
yeah. Oh, actually, yeah, this was one here. Yeah, so that would be minus of 3 and 5 would be 3 minus 1 2.
Yes.
So we
Yes.
can move on to
Okay.
the next index and keep going
Okay.
like that,
Yes.
right?
Yes.
Do you see it?
Yes. Yes. Okay. I get that. Okay.
Yes.
Oh my God. Okay. All right. Okay. 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 So at every index, we were basically trying to. I mean, we split the array into left and right and find the left and right peaks from there one. Okay. And okay, and then we go on and we start calculating. Okay. Okay. I think I can do that. Okay.
Yeah. Okay. Let's try it.
Okay.
I wanna see.
Okay. Okay. So we get the left peak, which would be nums of till I. Um, right.
So right now you're taking
And
the sublist on the left and right. So how do you
yeah.
find the peaks?
Oh, the peak. Sorry, my bad. Okay. 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 I should also probably check for the length of the sublists. That would. Um,
Right. So in which cases would your sublist be empty?
when it's at I equals 0 or I equals len minus 1.
Yeah, exactly.
Yeah. Okay. Okay. Uh, okay. So in that case, I'll just skip.
Yeah, makes sense to me. I think you meant to put the equals here.
Yeah. Sorry.
Yeah, no problem. Like in the interviews, like if you do like typos like that, like no problem.
Yeah. Okay. All right. So now I have my peaks and there's a. Okay.
And remember the case where we were overflowing?
The
Basically,
overflow.
yeah, when we had a negative value.
Oh. um, Negative.
So, do you know what I'm talking about?
Yeah, I'm trying to recollect that case where we encountered a negative value.
So it was when we were on the peak.
Okay, on 5. Okay. Here is 3 and the peak here is 2.
So you would take them in and subtract 5,
Okay.
right? So you would have negative value, right?
Oh. Oh, okay. At the time, okay, I was subtracting 2 from it. Right, right. Okay. Then I would not consider that. Okay. So only if it's greater than 0 do I add it to my water variable.
Yeah.
Okay. And then we go forward. Okay, okay. Right. And then I think we could return water here.
Okay, okay. So does this work?
I have to test it. Let me do that. What happened? Hmm. Is it going in infinite loop somewhere or?
Uh,
Hmm.
I think it. Wait, let me. Yeah, it seems to be stuck. Oh
Yeah,
yeah,
but
yeah. Okay, I see it.
oh, okay. The I would not get incremented. Hmm.
Right. But if you do that, does it work?
I don't know. I was just thinking about the first case. Zero. Then we consider in the first element. Okay, do nothing. Okay, then we consider the second one. Then we can start T sequence. Why would it be an empty sequence? I plus one is at two, so it has at least one element.
Mm, actually, I'm not sure. So how would you approach debugging this?
I would print out the value of I.
So right now the list is of length 3, right?
Yes.
So if you're slicing from
I
3,
plus one. Okay. 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 But it should not. So when it's at two, it should just end the loop. Oh, okay. Okay.
oh right, I see that if it equals to 2, it will enter in this if statement, it will continue, and then
Mm-hmm.
it will increment. So I would actually, it should print in that case, right?
Yes. When it goes three. Hmm, what's wrong?
So like bugs like this can be really like deadly in real interviews, because like you have to fix them, but like if you don't find
Yeah.
the solution, you like lose so much time. And I think like mostly the reason for this bug is like,
This is the this is the counter value. Yeah, it's not.
yeah, maybe like using a for loop and going
Yeah.
in the range of like 1 to the length of nums minus 1 would like avoid any bugs of this
Hmm.
kind. Good.
That's the result. Okay.
Yeah, that's the answer. So does it work for more complex example?
Yep.
That's what I want to know. Oh, so it is working, right?
Okay.
Okay. So one last thing, we have like 4 minutes left.
Uh
So
huh.
what's the time and space complexity of your algorithm?
I'm thinking time complexity would be O of n squared because for every element I, it scans through the whole sublist and returns to me the max, right?
Yeah,
So
yeah,
it definitely visits every element for every element. So O of n squared and
yeah. That's right. And the space?
yeah, constant space.
Okay, I missed it. Sorry. So yeah, that's correct. So I
Okay,
think we'll end this here, and I'm gonna give you some feedback. So to be frank, like this question is like really challenging if you never saw it before. So
hmm
I had this exact same question and I never saw it before. Like once you see the trick, it's like I think it's pretty simple, but if you don't know it,
yeah.
like there's so many like ideas you can have that can like lead you into a dead end.
Uh-huh.
So like when I did my interview, like it was like on a piece of paper, and what I ended up doing is like turning the paper upside down and like drawing lines where like the columns were in between valleys basically. So I came up with like the worst of solution. It was like n times the max value of the height. So
Uh-huh.
basically it was like, let's say you have a height of like 2 billion, it would just time out even though you had like three heights in it. But like even though it was such a bad solution, I think like the important part is like that I explained it intuitively.
Mm-hmm. Mm-hmm.
So I think
Right.
they really like that. So I got an offer even though like my solution was suboptimal.
Uh-huh.
So the actual solution for this problem is like in linear time, and the
Yeah.
best space complexity is like constant
O of
space.
n?
You can
No?
do it with like two pointers.
Uh-huh.
So this idea is actually like really good. The max of the left and the
Yeah.
max of the right. It's
Yeah,
just
I
that
could probably, reduce that, and pre-compute that for each and every index and store it, and then,
yeah, exactly.
uh,
So you know how to do it. It's just like if you just say that you could do that and like do this, I think like the fact that you know how to optimize it, but you want to
yeah,
make it simple is like good in itself.
yeah,
So
yeah.
let's
But that would
address.
be O of n space. I don't know how to optimize on the space then.
Also, so that's another trick. So basically, since it gets even more complicated, since we know that the value at a certain position is constrained by the minimum of the
Mhm.
max to the left and the right, we can use a two pointer to like compute the minimum of the max to the left and the right. So you start at like both ends. I can pull up like the constant space solution on my screen. Like if you're watching the stream, I have it on my screen.
No, let me open it up. I think it echoes, so I just close that.
Yeah, you can mute it and it will be fine. So
All right.
basically you can have a pointer to like the left column and the right column, and you
Mm-hmm.
always like either decrement like the right one if it's smaller. uh, yeah, exactly. You increment the left one if it's smaller, or decrement the right one if it's smaller, because basically your minimum will always be constrained by the minimum value of the like the left peak and the right peak. So like each time you do this comparison, you like increment or basically move the smallest of the two pointers and add the value to the column you reach. So it's really not intuitive. I actually like looked it up today, and I was like, whoa, this exists, and I was impressed. So this is not the kind of solution you want to like bring up in an interview. I'd say like maybe like mention that it's possible, but it doesn't really prove anything about your skills as like a communicator or like a problem solver. It just shows like if you figure out by your this by yourself, like I would be pretty impressed. Like in the beginning you were mentioning two pointers, and I was holy cow, is she gonna figure this out by herself? I was like so nervous for you. But yeah, it was close to being this solution you came up with. And it looked a little bit like this. It's like moving the pointers around like the smallest peaks, and you know like the next column you reach is like constrained by that peak. But anyway, so one second, just okay, okay. So oh, I lost technical problems. Please wait. Yeah, okay, I got it. So back to the feedback. So basically the question that I have around the feedback is like, how do you handle like not really knowing where you're going? So I think when you don't know how to solve the problem, you have to focus on like how you communicate. So really like getting the most information you can out of the interviewer. So I think at some point like you were like trying to think about how to implement your solution, and you like stop talking a bit. So if you want to do that, I think you should like let your interviewer know that, can I think for a moment? I think I have an idea, but I'm not sure how to. Like you did that a few times, but sometimes you just like went silent without like any warning. So that can be like a bit awkward for the interviewer, I'd say. Like some people don't care, they're like understanding, but like the more you communicate, the better. And I think like you're maybe trying to find like an optimal solution. Like I don't know, from your point of view, like when you were trying to solve this problem, like you were trying to find like all the information like at the same time. Does that make sense? Yeah. No, you muted yourself. Okay, so I'll keep talking. So I think maybe the focus would be like trying to solve it in like the most brute force way possible. Like stop worrying about optimization and like worrying about something that works. Because when you have like the brute force solution, you can like build on top of it. But if you're trying to like go directly for something that is like efficient, but you're not sure how it works, or you can't prove that it works, well, it can hurt you more than having something brute force that you're sure is working. So if you can't prove that what you're trying to work on is working, I think you should avoid like spending too much time on it if you have something simpler that can be done. So like in my case, it was like just iterate over everything sequentially. Each time you see like a wall here, you increment each time you see a hole, and you keep going. Like each time you have a closing wall, you add everything in between. So that was my solution. It was pretty bad, but it worked. So I think that's the main focus of this problem. Like it's really tricky. So trying to find a brute force solution isn't that obvious, but I think if you manage to do that, it's already really good. And I think somebody that hasn't seen this problem that manages to figure out that brute force solution is like almost better off than somebody that just memorized like the trick of like knowing the left. It's even better if you can like figure it out on the spot, but this recurrence isn't really that obvious. So this problem is, I'd say, a classic. Like I had it personally, and I'm sure like I think I saw in the chat Lawrence had it in an interview too. So even though like it's better to figure things out by yourself, like since we're trying to gamify the interview process a little bit, maybe it's worth like studying it so you can like focus on your communication skills afterwards and like impress them in your communication skills. Because if like in an interview like you have no red flags in regards to your technical skills, then they're gonna turn like, is this person like a good communicator, a good team worker, etc., and like look at the other things. Like if they have no reason to like not hire you and you're like you're doing like everything perfectly in the technical regards, then you focus on the communication. Basically what I ranted about in my how I got my internship at Square video. Do you guys in chat have any other feedback that could be helpful? Of course. Like maybe trying to like break down the problem into smaller sub problems, but if you don't see like the general method of solving this problem, like finding the peaks to the left and the right, then it's hard to know which sub problems you have to solve. So I guess you kind of got unlucky in this sense. Like, yeah, it's really important, I guess, to know the general way. Are you still here, Ankita? Please respond. Yeah, I guess it's a necessity to know the classics, right? Like some things like this that is kind of hard to figure out, or either you like when you don't know like the classics like this, you just concentrate on brute forcing.
Yeah, I've been on mute. Oh,
Yeah.
gosh.
Oh,
Uh,
were you like talking and I wasn't
yes, I
responding?
was. Yes, I didn't realize I was on mute. Yeah, no, I completely agree with you. Yeah, the brute force was a little tricky to arrive at. Even when I was trying to solve for the smaller, you know, the smaller part, I sort of got confused to, the when I tried to apply it to the general problem,
Hmm.
the first one when it was 2 1 2, and then when you extend that to the 3 and 5, the second array, right? So when I was a little comfortable figuring out the value in that three in the first subarray, when I tried to apply that to the bigger subarray, that's where I got stuck. I mean, I could not figure out a smart way to, like, uh, decide upon your left and right pointers. So yeah,
Yeah.
that's where I was really stuck.
Yeah, I think it's fair. Like it's a really hard problem. So one thing to consider as well is like when you interview, you're always like compared to like the other people interviewing for the same place.
Hmm.
So your goal is not like to be able to solve everything perfectly. It's just like to show that you have something better than the other like potential well other contestants, let's say.
Right, right.
So either you have to like demonstrate superior communication skills. So
Hmm.
even though you're like not sure, trying to like work with the interviewer, because you have to consider your interviewer almost like as a teammate, because it may be that the case if you're like interviewing for a startup. Like for big companies, I don't think so.
Hmm.
So if you can manage to get hints out of me, like it's definitely better than like getting stuck and trying to figure it out because time passes so fast in like an hour. So
Yeah.
if you tell me like I'm stuck, I don't have enough information, or I really don't see where I'm trying, like the approach I'm supposed to do, like it will lose you some points. But like if you manage to like use the hints that I give you and then manage to find a solution, and then like just demonstrate like your superior abilities to like communicate. So if
Right.
somebody like communicates perfectly and manages to solve everything without help, then he will have the advantage. But like compared to other people that would just get stuck and get really awkward and stay silent, you would have an advantage.
Right. 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 That makes sense. Yeah, I'm gonna keep that in mind.
Yeah, so it's always like a strategy, like how much information do I need to get out of the interviewer, and like manage your time. Like if you think you can invest some time in trying to figure it out, like
Hmm.
do so. But like at some point, if you really have no idea and like you realize that you're just like playing around hoping that like the miracle solution will pop out, then it's better to like admit a defeat in the battle but not in the war, you know.
Right. Right.
It's
Yeah,
almost
you're
like
right
a
about that.
strategy, you know.
Right. Yeah. Yeah. Yeah.
Did you
But yeah,
have
this was a good experience. I don't have any more questions for you right now. I actually want to
okay,
thank you for this experience.
yeah, for sure, you enjoyed it.
Yeah, absolutely. Yeah.
Yeah, I hope you feel better now. Like I think you were a little bit nervous, yeah.
Yeah, I was, but I was more nervous when I couldn't figure it out.
Yeah,
Uh,
that's normal. That's why you need to try to get out of that situation, like either by figuring out, but if you know that you won't, well, it's okay to like tell your interviewer I may need some hints, and like I really just want to get forward, and like basically
right.
like show that you have some potential by other means than just getting stuck, you know. You need to have
Mhm.
something that your interviewer can hold on to like defend you as a potential hire.
Right, right. Yeah, yeah.
Yeah. So I really hope it will help you in your future ventures. So do you have any goal in mind? Do you want to work with Fang like the rest of us?
Don't we all?
Of course.
Yeah.
So thank you for being here, and
Yeah, thank you so much for taking this interview.
it's been my pleasure. See you on the binary search.
See you. Bye bye.
Bye bye.